Hello and welcome back to the development of the Feersum scheme compiler. So in the last stream we went over adding support to the compiler for vector literals. So we have support now to emit byte vectors and plain object vectors as a literal. So that's completed, and in the current stream plan is to finally get round to tackling macro support. So macro support I think is going to be one of these big tasks, and it's probably going to take several iterations to be able to complete and get it right. So let's start as per usual by going over what we did in the last stream. So most of the work, well actually the work was split across the three main sections of the compiler, and there wasn't really a main place. But let's start by having a look at syntax. So in the syntax we added these two new parsers, parse vec and parse byte vec. So parse vector expects the token we see at the start of a scheme vector, and then it parses some forms and then the closing brace. And byte vectors expect the U8 prefix, and then they expect a 8-bit integer, optionally with some white space, as many times as you want. And we have two new nodes in our syntax tree to represent these two new literal types. We've got vectors and byte vectors. Then in the binder, which is the next step in our compilation chain, we have support to bind those. So if we get a vector, we produce a bound literal of type vector. If we get a byte vector, we produce a bound literal of type byte vector, and we just pass the body of the vector or byte vector on. So in this case, the body of a vector is actually an AST node, and that's because vectors are actually implicitly quoted. So if you have a vector that contains any kind of like list form or anything like that, it doesn't evaluate it, it's actually treated as being quoted. So, and they behave in a similar way to a quote. So you see down here, a quoted form has a AST node and produces something that is a quoted form from that AST node. And then the byte vector just has an array or a list of bytes. So the binder part wasn't too complex. When it comes to compilation, we have this emit literal, which has two new cases. For a vector, what we do is create a new array of object. So we create an object array because we're using object arrays to represent vectors in this scheme implementation, and then effectively just flatten the syntax tree we were given into a series of quoted forms. So if it's like a list of integers, then we basically load those integers onto the stack, but if it's something like a more complex form, we'll produce some form of list. And so what happens is that at compile time, when we're producing the IL for our program, we will emit all of the IL in a big unrolled loop effectively for all of the different bits, and they will then go and set each index in the vector to whatever we're expecting to set it to. And at the end, we leave the vector on the stack. So that produces the result. For byte vectors, in the stream we initially did roughly the same thing, except for instead of emitting quoted things, we loaded a byte onto the stack. But since then, I had an investigate of how how the Roslyn compiler does this. So let's go and show you on SharpLab what happens. So if we've got a byte vector and we do something like new byte, and we give it 1, 2, 3, and it's expecting a semicolon. The IL for this is going to be interesting. So what it expands out to is a load token for this field, and then a call to the internal runtime method, which is, this is actually an intrinsic called initialize array, which will effectively copy the array value from a specific field into this new array we've produced. So effectively what we do is create an empty byte array, do this call to the intrinsic, and the byte array is filled with the bytes from this specific field. And the way that field is represented is that we have this private class, private type definition is actually a value type. So it's something that would be copied around rather than something that would be heap allocated. And it's got an explicit layout, and the layout size is set to the same size as our byte array. And then when we create this field down here, this private field, which is of this special type, and we set the initial value to a byte array containing the bytes we care about. So effectively what we do is we fabricate a new type that is exactly the same size as the byte array that we want to represent, with the same alignment and stuff. And then we say that the value for a new instance of that happens to be this specific set of bytes, and then use the compiler intrinsic, the runtime intrinsic, to copy that byte array. So that's how Roslyn does it. We take a very similar approach. So if we actually have anything that we need to initialize the array with, we create a new type definition, and our type definition has explicit layout. We say that it inherits from value type instead of inheriting from system object. Set the packing and layout options, and then we create a new field that is of that type and set the value of that field to be our bytes. So what we do, we just turn our F# list into an array of bytes and set that, and then we emit the call to the intrinsic. So we import reference to the initialize array method, load token for our field, and then emit the call. So we're doing the same kind of sequence of events that Roslyn would do. Now, what I have noticed is that if you make an array that's got fewer than 3 elements in it, Roslyn won't actually bother with the whole nested type and all the rest of that, and will instead just do what we used to do in the stream and emit a series of load constants and then store elements, where it effectively builds up all the values into your list one by one, but it only does that if you forgot 0, 1 or 2 elements in your list. But for simplicity's sake, I'm just going to always do this if we've got elements. So I imagine that the reason why Roslyn only does it if you've got more than 3 or more elements is because it's probably going to be slower for short vectors. but I don't think that's going to be a huge problem, slowing down people using byte vectors that have only got 2 elements in them. So that's byte vector literals, and that means that we can now do things like this and have that expand out into a byte vector, and the corresponding vector ones also exist. So macros. So in Scheme, a macro is a way of defining some new syntax partway through your program. So you can introduce new expressions. So schemes are built around the idea of special forms. So some expressions like an if or cond case or something like that have a special meaning to the compiler. And so when you reference them, instead of it turning it into a function application, it turns it into a special something that means something different. So like in the case of an if, it won't evaluate the arguments, and that's a key thing to all of the special forms. It doesn't evaluate the arguments before the call. It basically passes all of the syntax effectively for the arguments through to whatever it is that's handling that special form. And a macro provides a way of defining those in your code as well. And it does this through patterns and transformers. So let's go have a look at what the spec has to say about macros, so that we know what they look like first. So macros come in a few different types. There's a let's go have a look. Derived expression types. Try to find the definition before. Syntax definitions. So you have a defined syntax, you give it a name, so you say like define syntax and then whatever you want the macro to be called, and then you have this transformer spec. And a transformer spec is effectively a way of specifying a set of patterns and all of the transformers for those patterns. And that's what this macro section talks about. So it says that new derived expressions called macros have the syntax keyword datum. So what that's effectively saying is that if you have a form where the keyword matches the name of a macro, then all of the what appear to be arguments to that are passed through to the macro and then expanded into some other form, which is then bound again by the compiler. And you can actually have macros that reference other macros, so effectively we keep on transforming things until eventually there are no more macros. So let's find the syntax case. So the pattern language is the place where I want to start. So each syntax rules contains a list of literals, which we're just going to ignore for the time being, and then a list of syntax rules. And a list of each syntax rule is a pattern and a template, just as a pair. And the pattern matches this pattern language, and then the template is is substituted using some expansion based on whatever we got when matching the pattern. So the plan for today is to try and come up with a representation for these patterns in our compiler, and then come up with a macro expander or some kind of tool which is capable of matching these patterns against syntax trees, so that we can at some point in the future, parse syntax rules, definitions into something that our compiler can use. But first, I'm going to start off with patterns and matching them against syntax. So I think a sensible place to start here might be to make a new file. So let's go do this. Now let's do it here. I was going to do it with INI, but that messes up the project file for reasons I've yet to fully understand. I think it's not expecting or doesn't understand our projects because our project is a tool. So it's a .NET Global tool. Well, I call them global tools, but yeah, it's just a .NET tool. And every time you add a file in here, it will strip out these two, and it's just really annoying. Maybe I should file a book, but macros.fs. So we'll start off. Our macros need to, where do they want to be? So they're going to depend on the syntax. So we'll put them here for the time being, and we can move them further down if we need more stuff later. But I imagine that they can't go too far down because binders are going to consume macros. So it's either there or one step further down. And let's go and add a set of tests for this as well. So we've got syntax tests already, but they're mainly for things like literal characters and that kind of stuff. So I'm going to start a new test case for macro. Macro tests. So we want to do the same thing. I think we're going to want the syntax factory, and maybe we will make macro tests. What are you complaining about? Ah, yes, it's because I haven't included that in here yet. Probably could have done that one with INI, but does this build? So effectively a macro pattern, we'll want some kind of type that we can match, some kind of type that we can parse the macro patterns into, and then we'll want some kind of method which will take a pattern and a syntax tree and return some kind of result. So let's say type macro pattern it's just going to be unit for now. The macro pattern type used in syntax cases to define the form okay. So we've got a macro pattern type, and then we will have a, what should we call it? Macro match, I guess. and it's going to take a macro pattern and it's going to take a syntax tree. Is that the correct type? Don't know. And this is going to produce a result of some kind. I don't know what either of the error types are going to be yet. What's going on here? Open syntax, yes. And that wants to be unit. Actually, we can do that, can't we? Attempt to match a pattern against a syntax tree. Returns okay if pattern does not match given node. So if I'm going to expose this so that we can unit test it. Maybe in the future it won't actually be public, depending on whether or not we actually need it anywhere other than within the macros. It could well be that this macros module is entirely responsible for doing all the syntax transforms that we need, and it does the match and the expand all in one method, but we'll see where we go with that. So macro tests, this isn't looking too compiley. No, I'll compile now. Right, fact. What are we going to call this? Well, we should start by having a look at what the different types of patterns are. So we have a pattern is either an identifier, a constant, or one of the following. So let's start off with identifiers. I know that yeah. Let's start off with constants. So patterns with constant match. What are we going to do? This is going to be, we can just fabricate the macro pattern for the time being, and we'll say it's a macro const number. We only have a few primitive types. we have the literal bound expression form, which represents some of those, but we don't have a literal type in the syntax tree yet, and I'm not sure that we do want to have a literal type in the syntax tree, because I'm not sure how the vector pattern stuff works yet. So it may well be that we do end up like having to treat vectors as literals in some places and not as literals in others, because we need to be able to pattern match against them. So if we've got a pattern which is 101 and then we say macro match pattern against, and we need a syntax tree here, so we're going to say, what is it, number syntax factory dot, that's got the dummy location and node. I'm wondering whether or not syntax factory needs to grow some extra methods, so we could do like syntax factory dot number 101. Let's try that. So macros is complaining because we don't have any kind of definition of constants and stuff yet. Constant of macro constant. Double. So that's macros, hopefully happy. And no, it's not, because I've not spelled constant right. No, I have. I've just not got the right amount of brackets. Yes, I've spelled that wrong. Consonant is one of my favorite. Right, so let's go and add syntax factory. Node. Let number n is node AST node kind number n. Let's do this as a pipe chain because we can. Node. And is that really a float, not a double? That should probably... Oh no. So a float and a double is the same thing. So did I mess up macros? Does that... Sure. Let's turn these into doubles because double makes a little bit more sense. So number produces a syntax node. Does the macro test match? That's gonna is don't know. I'm gonna say results dot bind map. Really, I just want to know that the result is okay. Match equals. No, can't call it match. What are you upset about? Result unit. Oh, hey Baduda. Well, I thought doubles and floats was the difference between 32 and 64-bit. And I thought doubles were 64-bit floats. But it looks like in F#, float is a 64-bit float, and double is also a 64-bit float. And I think that's because they have single as well. And single is float 32. Can we do float 64 then? Is that a thing? No, we've got float and float 32. Okay. I prefer double. Didn't mean to do that. With .NET, floats are 7-digit, doubles are 15 and decimal. Yeah, that is true in C#. The names are float, double, and decimal. But it appears that in F#, although the actual .NET types are the same, like system.float, system.double, the F# names for them are different, or more specifically just float is different. So it just makes float bigger. And I think that is because the way F# handles numeric literals is particularly picky, and like if this was a single precision float parameter rather than double, I wouldn't be able to pass this literal in without casting it. And so by making double precision floats the default, it means that you can write like let float something like this, let float equals, and that will compile. Whereas if float was 32, which apparently is called float 32 or single, you end up with an error. But then you can put S, I think. Can you? What is it? L. Maybe we'll end up with a hint. No, it just says expected single. No quick fixes available. There is some suffix you can use on the end of there. Is it F? Yes, it's F, which turns it into a 32-bit float. I don't. Yeah, the fact that the suffix is f, but I could write something like single. I could write f equals float, and then put the suffix f, which matches up with f. That's not the same type. I need to do d because clearly, or whatever, and then m, as you say, for decimal, which I think is just called decimal in F# for reasons. Yeah, float 32 is 4 bytes, float is 8, and I don't know if there is a float 1 to 8. I think that, yeah, so it seems like we've got a bunch of type aliases for, there are only 3 different float sizes, and the type aliases are different in the different .NET languages. But for this project, everything is decimal. I haven't actually got round to supporting what are called exact numeric types in Scheme yet, so everything is decimal. But that should be fine because having double precision floats should leave you with plenty of like integer values that you can represent exactly. I didn't know about arbitrary precision stuff. I haven't actually looked into arbitrary precision stuff. I do know that there is kind of this perception that the decimal type is for currency, and that it's because it represents things in base 10. Well, I've heard that bandied about, and I kind of always assumed that was the way it would work. But then, having looked into it, it is a floating point value, not a... Yeah. Numeric types, there's lots of them. I was also surprised to find out that there is a complex type as well in .NET. I just never ever needed it. For some people, accuracy is important. I think, as far as I understand from the Scheme spec, you can be as accurate as you want, really, as long as you're at least as precise as 64-bit float. You are allowed. It does actually say that you are allowed to use floats for everything. The only thing is that they have that all your numeric types need to match the different levels in what they call the numeric tower. So if you do support integers and floats, they have to work in the same way that the Scheme spec says. But they do allow you to just use floats, because I think, is it JavaScript that technically doesn't have anything other than floats or something? So I don't do JavaScript, so I don't know. I think it was added in so that people could write Scheme compilers in JavaScript. So, our macro match, we want a way to assert that this is okay. Is there a way to do that in F#? I don't know. How to test option types with XUnit. Just match it. JS spirals everything to numbers with or without decimals. Yeah, JavaScript numbers are always 64-bit floating point. Just like in my Scheme compiler. Yeah, but I do believe that that can't be the only environment that people have tried to provide a Scheme implementation for that's got restrictions like that. But I think that the fact of the matter is that for a lot of cases, 64-bit floating point numbers will actually get the job done. There is a fairly large amount of the integer, well, real number space covered. So yeah. And the fact that you can still precisely specify. I think Schemes says something like you have to be able to accurately specify all of the values that could be used for array indices. So I think that's fine, because you would be able to just say that as soon as precision is lost and you have to start floating the point in your decimal value, then that's too big for it to be an array. Vector, sorry. But vectors are arrays for this implementation. No one really seems to be coming up with an excellent F# assertion library. Really, I just want to say, check that this resource is okay. In Rust, I would just unwrap it, but doesn't really seem to be anything useful that I can do here. The only thing I can really do is match on it. I guess we can just say if it's okay, do nothing. Otherwise, do we have an assert.fail? Nope. I think in XUnit you're just supposed to throw it. Is that acceptable, or do I need to do some kind of coercion with that? With fail with message, the exception message. Yeah, well, you want fail with I'll have to live with that for the time being. I mean, we haven't actually implemented anything yet, so someone must have written a decent assertion library for F#. I'm just not capable of finding it. XUnit assertions. Assert.equal, yeah, fine. This is always going to match for the time being. So let's try and actually do something. So what we need to do is match over one of these things. And then check that the syntax node matches. I think we need to match over the pattern and then inspect the syntax against it. So it is, if it's a constant, then we need to say if it's a number, and then if it is a number, we can go n. If the number is equal to the constant value we were given, well, actually, what is number here? Number is a double. That needs to be ast node dot kind and ast node kind dot number. If they match, we do OK, and if they don't match, we'll do error. If we got any syntax node other than a number, it's an error. If we got, and we don't actually know anything other than constants yet, and that's error, isn't it? Result, oh dear, have I've got some values aliased by accident there. Obviously these result types, well, obviously, hopefully in the future these result types will have more information in them. Than just a unit value. What are you upset about? It's because it's kind with a capital K. Does this pass? No. Well, it doesn't compile. Macro constant. What do we want to do here? I mean, I can say if it is a constant number, which is really the only thing it could be here. But do I want to do this whole match for every single type? It may be better to do constant and then match every time we see, for each AST node kind, if we see a number, check to see if we're expecting a constant number, and if we see a boolean, check to see if we're expecting a constant boolean. So I think the result of the OK case is going to be a list of bindings. So if we've got an identifier in our macro, we want to know what it matched in the pattern. So I think that's what the OK case is going to be, but I've not decided yet what the error case is going to be. I don't know whether or not we're going to want to produce a diagnostic if a macro doesn't match, or if we're just going to say couldn't match the macro. May well be that we want to produce something here to tell you why the macro didn't match. It's like expansion error, and then say like it was failed because we were looking for a constant but we found a form or something, but we'll see. So the next thing is an identifier. Well, actually we haven't done all the constants yet. Let's do all the constants. So what are the constants? Let's go have a look at the binder. This will tell us what all of the different literals are. And macros. So number, boolean, character, string, vector, don't think we're going to have, and null is actually an empty form, so that's also not really a constant. So if we get a constant, what we could do is match both of them at the same time. And then say if we got a number and it was a constant number, and let's do them n and m. And they equal, return OK. Or if we were expecting, if we got a AST node dot boolean and we got a macro constant, if b1 this is starting to look repetitive, but we'll see. If it is an AST node kind string macro constant, if we got both strings, return if s equals t, then this is starting to feel an awful lot like we should have a syntax node kind for constant that we can then use in the macro patterns. let's go. That will probably simplify the binding of literals as well. So numbers, strings, booleans, characters. So these four here, if we change those into constant of syntax constant, and then we make a new type. Constant or literal value. So when we make the spanned node, that's more awkward. It's got to be a number turned into a constant. It's not that awkward. String turned into a constant. Boolean turned into a constant. Hello, new duck. How's it going? That looks red squiggly free. Let's get rid of this macro constant thing. Seeing as we don't actually want it anymore, we can say it's a syntax constant. And then if we're expecting a constant and the kind was constant, we'll say if k equals c, if I can stop flipping the lines around. Doing some JavaScript. I am writing a scheme compiler in F#, which is going well. I'd love to be famous. Just go deal with that chat. I'm not in the right view to do that. Require verified email. Why does one turn required verified email on? And also, why isn't that the default? Settings, channel moderation. Okay. Settings. Social status. Nope. I found the moderation stuff. Wonderful. My window was too small, so it had collapsed the menu and things just weren't there. Block hyperlinks. Well, I mean, yeah. And email verification, yeah, also. Yeah, that'll do for the time being. People can live with the fact that there's a link there. Right, back to matching constants against things. So yeah, if we've got a constant and it equals the one we were expecting, and then we can get rid of all this other stuff. What are you upset about? Expected to have type, yeah, but kind constant. AST node kind. Oh. There we go. That should sort that out. And we should be able to match against other constants now. So let's go fix up the rest of the compiler and then we can write some more unit tests for the other cases. So quoted kind. So in this case, I think we're going to want like a bind constant. Because numbers, strings, characters just aren't going to be a thing. And then we'll do emit literal bind constant. Or maybe we'll do like bound literal. No, we'll do bind constant. Are you commenting on F sharp or the way that I write F sharp there? As far as I understand, the syntax comes from ML. Is that right? Yeah, I think so. Bind constant C, CC. And then somewhere else, we've got a big match over all of the types. Bind in. No. What's wrong here? Ah, we're not in the binder. Maybe we do want bound. Bound literal from constant. We can do with I can never remember the syntax for this. Scope does it, I think. Nope, no, scope doesn't do it. diagnostics, member, you do like member static. So bound constant is going to have, bound literal is going to have from, or static from constant C, and it's gonna, actually we could do function, and it's gonna take static, yeah. So if it is a syntax constant number, we will make bound literal number. And then we just need to do the same thing for the other cases. So we've got character, string, boolean, and string. C, have to make sure the letters match up. So character, C, boolean. I don't write necessarily the best F# because I didn't really know it before I started writing this compiler, so I only know as much as I have needed to know to make this work, and that's going to be strut instead of string, because string's just too long, but boolean apparently isn't. Incorrect indentation, sure. So then in the compiler we can do bound literal from constant. So that's the compiler happy. What about eval? What are you upset about? I don't think it's upset about anything anymore. I think everything is good there. The interpreter is doubtless going to be upset about something. No, because that deals with the bound tree. Lower doesn't need to worry about constants. Program's happy, so it's just the binder now which actually needs to bind this stuff. So if we get a number, string, boolean, or character, we're gonna actually get one of these new constants instead, and what we're going to do is do bound expression literal, and let's do a pipeline, because why not? Bound literal from constant. Good. I'm not sure whether or not we're going to want byte vectors to be constants later as well, but we'll see. It doesn't have to make sense, Bear. It just has to make sense to me. They're probably written on different days, and therefore, I mean, look at byte vector. Byte vector is so long. From constant, that's pretty long as well. going to run the test and see if we end up with all tests passing, we can start writing some tests for some other constant values for our macros. I mean, constants are the easy mode. The next one is going to be, oh no, I shouldn't have started monologuing before the test's compiled. No overloaded match for the method equal. Syntax constant AST node. Well, that's upsetting. Yeah, I mean, that's not like a Rust compiler error, is it? That's just, you did a bad here, and then also here, and then also here, which, I mean, it's saying syntax tests 22, 23, 24. This is probably going to be because this. So we can make all of these constants. That's going to solve a fair swathe of the red. It's always the tests that catch you out. Yep. I'm going to put a space in the thing I've copied because it's just not helping. Right, then if this gets rid of most of the red, I need to come up with a way to deal with the node. And the fact that it was talking about overloads gives me an idea of a cunning solution. So, is there any more of these constants lying around? So I think that's going to be everything except for the case of node not matching. There's only 5 of them and then we'll deal with it. Oh dear. Spacing. Syntax utils is not happy because that needs to be constant. What about macro tests? That wants to be syntax. Tax constant. Unless, I mean, it's quite nice to have an AST node error, but it is also really upsetting when it aliases. What's saying? Is it just upset that I've used the word match in an identifier? I'm never entirely sure what if these things are going to go away when I compile it. Not all of them, apparently. So what is n here? Dummy location. But didn't we have these already? I'm going to open syntax utils, and I think that should work. No. Syntax factory. Long versus short names again. Dummy location. Get rid of. But we've still got the case that we've got n all over the place where we're expecting constants. Now we do have a shortening for that, which is the number. But we also don't have it for things like str and stuff like that. So what I am going to do is I'm going to add an overload of node, which takes a constant and then I'm going to say this is going to be if that's an AST node kind, we'll use that one. Node. Actually, we don't care. We'll try and just if it's an AST node kind, we'll set it there. And then for this, we'll just call node or what are you upset about? I'm sure I'll get over it. Can you define overloads in F#? That's what we're about to find out. Maybe? Nope, it's not working. I'm gonna back this all out. Yeah, you were right. Pipe forward. So just producing chains. And then the other one that's kind of useful is the double shift, which composes two functions. So back to the place which was actually broken. Syntax tests? No. Eval tests. So we'll say that this is syntax AST no kind constant. Just going to make a node from a constant. Wow, we are completely not compiling here, are we? Node kind not none. If node is not defined, maybe you want one of them following node kind. Syntax utils, eval, syntax utils. So I think the syntax utils is not compiling, which is causing the rest of it not to compile. Hopefully it's just because I messed up that space. These are all complaining about node being gone. Node is not defined. Right. Expecting AST node kind to A. Yeah, well, I think my next compile will have to be written in Rust there. Yeah, F-Sharp's been fun to try. And writing .NET IL and stuff has been interesting. But I'm thinking about something that targets WebAssembly. Yeah, it's just the errors are a little bit more complex. It doesn't just give you a like, oh, here's what you probably meant, just copy and paste this code. It does what you really wanted it to do. Style error messages. How about n? We get rid of n, and we, in our syntax factory, we have a constant. And constant does this bit, which really, this can then be constant. No. Like that. And then in the eval tests, every time we see an error because there's no n, we can change it to either constant. No. I think we want to open syntax factory as well. If I could spell open. I'm going to copy this preemptively. And then that's a constant, that's a constant, that's a constant. But some of these, like the sequence is not, so that wants to be node. Things are turning green. That's a node. That's a node. This has been awkward. Whoop. What did I click on there? So I think I want constant again. Constant. Let's do it top down so I don't end up accidentally clicking on that link. Node. And there's a few more down here. That's going to be node, 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 constant. See how many fewer reds we end up with now. Fewer, but not none. I like the fact that 9 is the largest that this is willing to suggest in a single file. More than 9 errors, yeah. That's because I've spelled constant badly. Fair enough. Did I copy and paste badly spelled constant? Maybe. Probably. Knowing me, yes. Node. Again. A missing node. That one also wants to be constant. There's probably a capital C somewhere as well. The lowercase c one is from the Syntax Factory, which is like a library for building up these syntax nodes for the tests. And it stubs out the position information. The one with the capital C is the actual type constructor. Because these tests were originally written when like number was an AST node, but now number is an AST node kind, we need a way of, well, it's not even an AST node kind now, it's a constant syntax constant. So we need a way of turning it from that into a kind and then into a fully fledged node with position information and stuff. So that all these tests, basically it's just a whole load of backfilling to make this roughly work. Is that only one? Only one error. Which either means we're very close to having done it, or we've confused the compiler so much that it can only tell us about one of the errors. The way that compilers tend to work is that if they detect some kind of syntax or semantic error, but they know that some of the input that went into detecting that also came from something that they thought had an error in it, they won't bother reporting the second one. And it's called cascading errors. And it stops you from basically, if you make one typo, saying that the entire source file is completely broken. Because, like, for example, if you broke the definition of node or something, you'd end up with errors all over the place. But sometimes it can mean that if you break it in the right place, you end up hiding all of the real errors, because the compiler effectively just gives up and goes home rather than trying to check your work. Although, given the fan spinning up sounds from this laptop, it's definitely doing its job. So, we've run some tests and some things have happened. Interesting. What has gone wrong here? All of our parser tests have changed. There's 32 failures. I bet we've got 32 things in our syntax tests folder. 30. Interesting. Bet there's some in the fail as well. Yeah. 32. So I'm going to update that set of snapshots. Go's default state, just not bothering to type check your work and giving up and going home. I had a good time writing a compiler once where I did such a bad job at the LLVM that it emitted. The LLVM just optimized the entire program to a single trap instruction, which effectively means you've triggered undefined behavior, I'm allowed to do whatever I want, which I found very amusing. And I mean, I guess under the C specifications, if any part of your program could trigger undefined behavior, it's perfectly allowed to do that. It's just the classic nasal demon situation, which you don't really want to get into, but here we are. Rust does tend to be a little bit more forgiving with that. I do know that Rust sometimes suffers from the fact that it targets LLVM, and LLVM is really designed for C semantics. There are cases, I think there's something to do with like loops and stuff, where if LLVM can work out that your loop can never terminate, LLVM's allowed to assume that all loops do terminate. And so it's possible to write code that should never execute in Rust, and yet it does. I think we're still waiting for LLVM to actually fix that. I mean, either that or we'll just jump ship to crane lifting. It won't be a problem anymore. So, right, how about writing a second macro test? Syntax factory number. So it'd be really nice to make this a parameterized test. So let's see if we can turn this into a theory. So theory is if we have a constant no. Extension manager. If we have a constant Am I allowed to do that? Not a valid constant expression or custom attribute. Yeah, I figured. Yeah. Constant number. Test constant. Let's just make the whole thing a function and call it multiple times with different types of constants. So make a pattern from the constant and we'll say constant. So make a node from the constant. Maybe? Ah, const is it? And that needs to be double. Okay. Test. Zero char I'll do. What else we got? Boolean. Let's do both true and false. 100% coverage. Stra. Accidentally switching the Bluetooth channel on my keyboard. Good. Hopefully they all pass. Do they pass? This is one fails. Yeah, one fails. No data found for macro test.patterns with constant. Didn't change it back from a theory to a fact. This is not the usual problem, which is if you don't have any, usually if you have a theory, you've got like A, B, and then you get rid of the theory parameters, you're left with that. But that's not actually a function. To put the unit parameter list there. That's been the source of a fair number of problems. Right, so we have coverage for macros matching constant values. Let's commit this. So binding constant values, compiling constant values, macros so far, syntax support for constants, actually switching to the syntax factory in the eval tests, macro tests, no, macro tests themselves, switching syntax factory, syntax factory itself, and then a whole load of parser changes because everything is now a constant. Why is that called 3? These are called like parse vectors. Bad strings. Interesting. It's called parse_fail/. Okay. Interesting. Fair enough. I've done a bad job of combining paths somewhere along the lines, but if it works, it works. So we say this is macro pattern and initial macro support macro patterns for constant values only. And let's publish the branch. So next up is the next easiest pattern to support, which is an identifier. Which we'll call an ident. Or will we call it a variable? Because this is kind of like a pattern variable. So if you've got a pattern variable, we just return the syntax node. So we need to make the result type a list. So we'll say result.ok. And the list is going to be of pairs of variable name to binding, I think. So we'll say it's the variable, damn it, change the Bluetooth channel again. And the value is going to be node. So this needs to be, the OK value wants to be a list of bindings, effectively, string to syntax nodes, but we should probably give them a type, shouldn't we? Type macro binding. We'll just use this as an alias for string AST node. And we might as well make a list of macro bindings as well. Actually, it's not going to save any typing. So return a macro binding list. Run the tests. Failed to inherit incremental branch configuration. Well, oh, I know what that is. Git versions are set. So we want to say anything that's not main is a feature branch. Don't know the best way to do it. I'm actually tempted to just say it's anything that's not this is what I'm going to do. No, that's not going to work, is it? It's too cunning. I don't know what regex language this supports. Let's just do a negative look ahead and hope for the best. Have a good one, Bear. I'll see you whenever. Do we get mystery errors from Git version now? I'm going to claim that as a win. So we've got our macro patterns. We need to write some tests for identifiers. So really an identifier matches anything. So we might as well say that's what the test is about. Ident patterns match anything. Oh, variable patterns, aren't they? That's what we call them. So test we'll give some syntax to this test, and what's he going to do? It's going to make a pattern, which is going to be a macro pattern variable test, and it's going to match it. Against the syntax. And we would expect to see a single thing which would be variable name test and s, and then say same. Yeah, we want to check that the syntax that we originally passed in is the same, and that's the wrong way around for the expected actual bit. Anything else is an error. Pattern variable did not match. So we will test a variable match against, well, what we might as well do is against all of the constants we came up here. So let's just maybe that works. Seeing a lot of red squigglies. It's going to be a macro pattern. Expected to have AC node, but here it has syntax constant, whereas here 45, because this one's to be passed to constant. Oh. Maybe. Don't know what the other red squigglies are about. Expected to have type unit, but it doesn't anymore. Macro match does not have that type. Oh, does it? No, it has a macro bounding list. You just have it. Type unit does not match the type syntax constant. Of course. Brackets are in the wrong position. I should multiple cursors this. How about now? Does it compile now? Yes. How about actually running the tests? Wonderful. So we can match any of those constant nodes, but what about test var match of something like an identifier? So if we make a node out of that, we can get rid of these syntax constants off the front of all of these Balux things. Nope. How about how about we match it against an empty form? And how about we match it against a form which has got an identifier in it? That needs to be made into a node. And how about number, which we have a helper function for. If I close this and reopen it, it's going to actually improve things. No. Project loading. Well, is it OmniSharp? Nope. We should, we are doing the assertion to check that the syntax that we passed in is what we got out. Let's commit that then. Pattern macro variables, I guess. Macro variables. They'll become more useful when we can start nesting these things, which I guess is the next thing. So a pattern is either an identifier, a constant, or one of the following. So it's time for a one of the following things. It could be a list of patterns. Does this mean Oh yeah, so in this case, ellipsis means they've literally put the ellipsis. Dot is the literal dot, but dot 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 means one or more. So it could either be a list of patterns, some non-empty list of patterns, dot an end. Maybe some patterns, then a pattern followed by ellipsis, and then maybe some patterns, or the same thing with a dot at the end. So how are we going to represent this? So I guess we want form. Do we want to separate out the repeating pattern stuff? Or do we want to have each one of these bound into a separate thing? Let's try and just match this for now. Well, this and this, we don't want to. I don't want to have to worry about the user supplied ellipsis stuff yet. I'm not looking at vector patterns. Template. Yeah. So it could be a form. Oh dear, I'm seeing the diff view again. A macro could also be a form of macro pattern list. I think what I'm gonna do is treat these two separately, forms and dotted forms. So we'll have a macro pattern list and a dot. And so if we separate that, and then we can have this could be a pattern type, like the repeating pattern thing with the where you put dot 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 after it could be a type of pattern as well. For when you do the ellipsis stuff. So we'd have like an ellipsis pattern. Right. So now we need to take into account forms. So for a form, we need to match kind. If it is form, what are we going to do? Well, we know what we're going to do if it isn't a form. We're going to just return an error. But if it is a form, I think what we need to do is list map. Is there a map to? F. So we want a mapping which takes 2 elements. And we want the 2 lists. And it bounds the collection yourselves. We're also applying first input list, the second input list. I want to know what happens if the lists aren't the same size. Yeah, what happens if, well, we've got a list of patterns and we've got a list of items. Well, we don't have to deal with ellipsis yet, so we can just write it in a sensible way and then deal with that later. So we can say we've got a pattern and a node will return macro match. This is just macro match, isn't it? So this needs to be recursive. Macro match FG, is that the right round? Yeah, maybe. And then we need to do result result. How do we turn our list of results into a result list? Results dot or C. I'm thinking about this. Is it collect? Because map error bind maybe. So that's why I'm taking two results and compiling them together, but we've got a list of results. What we could do is fold. So I'm thinking, because like doing the list map 2 is going to mean that we end up processing the input list and the thing we're trying to match the macro against pairwise, which won't necessarily always be what we want to do, because when we've got when we're expecting like one or more of something, it's more like we have a stack and we really want to start matching from the end. We might have one pattern matching more than one thing. But just for the simple case, we can just do like a collect. How's that going to work? List. What is collect? You want like a result.collect with. Result really doesn't have a lot going on for right in F sharp, does it? results. Do we have anything interesting in here? We've got the collect again, compare exactly one, filter. Could we group it? Collect results. Let's just write it ourselves. It takes an input which is type results A B list, and it produces a result A list B. So how does it do that? Well, it says let so decomposing a list is going to produce something. Decompose can be a function. The idea of this is that we will match all the different things we could expect to see. So if there's nothing in the list, we return a pair with nothing and none. If there is an error at the head of the list, we return, it's not the right syntax that. If it's an error, we'll return the empty list and the error. If it is an OK at the head of the list, we will return do let results and error is decompose the rest of the list, and then we will return v on the front. And then what we do is we say let results maybe an error option what are you complaining about? Expected AST node given a result, because that's result. Okay. Result of error. So then we say match if we got some error, we return the error. If we got none, we return result dot okay. Results. Think. Is that gonna work? What does it think? It thinks it type checks. What does this think? The type macro binding does not match the type macro binding list. Takes a list of results, returns a result of a list of something. This is going to produce a list of then I need to do result.map with list dot flatten. No. Collect. It's not collect. We could do it collect. Is that gonna work? So in theory, this should now allow you to write a pattern that matches a form. So I'm going to try and write a pattern in the macro tests that matches just simple forms. Fact. Form or simple form patterns. Let's go and steal this test match thing. So test match a pattern with some syntax. And we expect to see, well, let's just have this do match if we got something. Get the bindings. Then we can do assert.same pattern is going to be macro pattern form of the empty list, and the syntax is going to be form of the empty list made into a node. Is that going to work? I'm seeing some red. Expected F# list of object empty, got an F# list of tuples which was empty. So the types don't match. Why don't the types match? Form match. I'm just going to close the editor and reopen it because code is not having a good day. What are you up to? Why is the types not going to match there? Is this because I think it's because I want to do assert.equal. Okay, and it doesn't know. So can I do that? Yes. They are lists. F# type inference isn't quite good enough. I think it's because there's an overload for t and an overload for IEnumerable t. It doesn't know which one to choose because the list is enumerable. Running some tests, and they all passed. 190. Glorious. So we've got an empty form matching nothing. How about a form? We should expect to see test and, well, let's make the node outside. Test node. This can just be a number. And then we can say in here we should expect it to be test node. And we'll do form match. For that pattern, and then the test node. And this has got to be a form with the test node in it, made into a node. And we should expect the pattern to be form with a macro variable inside it. Called test. That is an interesting assert statement. Does it work? We should also be able to check that we can match against a constant inside there as well. So let's do constants. So we'd expect this to match nothing, and we do a form which has got constant false, and then constant if, and then the constant of that number. What are you upset about here? That is because this should be Boolean str number. Number. So that pattern should be able to match a form which contains constant Boolean false a constant string and a number. I think that was the, yeah. And brackets, more brackets, but that should match. Right, so with that, I think the only thing that are to do in the macro patterns now is to do macro patterns should support we need dotted forms, and we need the variable number of arguments, but for the time being it works, and I'm quite happy with the progress that has been made there. So I think I'm going to call it a day here. Let's just compile this and see if there's any last questions before we go. Anything else that I've skipped over too quickly today that you're actually interested in finding out more about? Or any suggestions about whether or not you think this macro approach is actually going to work to implement the hygienic macro system that Scheme's got? I think we should be able to come up with a pattern language. If we have a pattern matcher that's capable of extracting all of the variables that you've got from your pattern, we can then pass those variables into a transformer and have that transformer produce the correct syntax tree at the end. The tricky bit with regards to hygiene is going to be when we come to then bind that syntax tree, what do we need to do with the identifiers that we see? So simple form patterns for matching some still no support for dotted forms or variable. Arity. Try to come up with a name for triple dot matches. Anyway, I'm quite happy. I'm also quite happy with this constant abstraction that we come up with, and it's actually simplified some of the binding as well, even though it's made the syntax tree a bit more complex in one way. It's made it simpler in another. And also looks like we're going to get to a point where we want to write patterns against vectors as well. So I don't think vectors, although they behave like self-evaluated quoting forms in some ways, they're not really literals. Anyway, so that's where I'm going to leave it. In this stream, we've sorted out macros. Well, we started to write support for a pattern language, which our macro system will use to match syntax trees and then extract the variables that it can pass to a macro transformer. So in the next stream, I'm going to continue looking at the macro system. So we might have a look at starting to pass some syntax definitions into like the actual syntax definition form in Scheme into macro patterns and transformers, and start trying to transform things, or at least start working on the transformer system, even if we don't have support for actually defining them in our scheme yet. But thanks for watching, and I will see you next time.